So in my last class, I discussed several topics in chapter 1. I did not discuss all kind of homework problems. So you may, you might have seen some problems I never discussed in the class. Okay. So there are lots of problems, homework problems. I usually assign the review problems and the challenger problems to you. Okay. Now those problems, if you compute them directly, you can always get answer. My point is whether you find the best, the shortest way to solve the problem. Okay. And as long as you know what is the best method, you're trying to find out, then you should find out. Okay. But there are some problems you needed to prove. Okay. This is usually you never done this kind of problems when in the elementary school, but in the middle school and high school, you will see some problems you have to get proof. Okay. So I'm going to discuss a couple of problems from the homework, how to prove some statement. Okay. The first problem I want to discuss is this one from the book in challenging problems. Okay. So you define a plus b in some sense. Okay. And equals a. So that's a definition, right? So a, this is a notation. It's equal to a. And you want to prove that this is associative, but not commutative. Okay. So the reason it's not commutative, it's clear that because b plus a, that's going to be b, right? So in general, a is not going to be, therefore, from here, you can see that, right, is not going to be b plus a. Okay. So that's why it's not commutative. Now, whether this is going to be associative, we need to compute this. Okay, first. So according to the definition, there is two variables here, right? And this is going to be a plus b, right? You only take the first part. Then you only take the first part. That's going to be a, right? That's coming from the definition. Now, right? Then you look at this, and you find out this is just only one number, right? So a plus some number, doesn't matter what is the exact number. So it's always going to be a. So therefore, you always have okay. So therefore, it is associative. So this rule is associative. So we prove that. You have to verify without using specific value for a and b. Now, in ACT, you will see some problems like that. Give a definition. Yeah, define a plus b. What is the value? What is the value of the 3 plus 7, for example? Okay, because our definition you only can see the first part. That's just equal to 3. Okay, that's coming from the definition. All right, the second problem is, yeah, if a, b, and x, y are numbers, show that, okay, show that a plus b and x plus y is going to be ax, ay, bx plus by. Now, when you prove this, you need some formulas. It's better when you try to show all the details, and I think it's better to also mention the rules you're going to apply. Okay, so we're going to apply some formulas mentioned in the book. Okay, so we're going to prove this. In other words, we're going to using some identity like a, b plus c is going to be ab plus ac. Maybe another formula is a plus b, and times c is going to be ac plus bc. Okay, so those are the two formulas we're going to use. Now, So now, if we have a plus b, x plus y, right? Multiply. So you view a plus b as a one number, okay? So according to the first formula, if this first formula is 1, that's the second formula. So you can say by 1, okay? So it's very clear. So it's going to be a plus b, that's only one number, and times x. And here a plus b times y, okay? So now you have, so now you use the second formula, right? You can say by the second formula, and that get ax, like the bx. So every step you have to do, you have to do legally, using some formulas you already mentioned in the book, okay, or in my notes. You cannot create your own one, okay? So here's ay and plus by, right? By the second formula. Now you have ax. Then because addition is commutative, so you can switch around. If you look at the expression here, x first, ay second, so you have to probably have to rewrite it like this. And it interchanges those two terms, and the bx and by, okay? Then that is a complete proof. So I want to see you give all such details, detailed argument. And every step, from one step to next step, you should know what kind of rules you're using, okay? Right? What kind of rules you're getting. You cannot create your own rules. In the mathematics, we have a certain rule set in the formulas in the book. And those formulas, actually, we prove that. But you don't need to repeatedly prove, you just use them, okay? Then you can do the exercise. But you have to, in your mind, you should clear which rule you're using, okay? And so that's how do we prove this statement, right? The second one is, this is just simplified, okay? Simplified, you needed to remove the parentheses step by step. I think the first step you have to do is, it's a, right? Minus b minus parentheses minus c. So you have to plus minus b plus c, okay? Minus a minus b minus c. You remove the parentheses inside the parentheses first, okay? Second, okay? Then you remove this bigger parenthesis, okay? You remove this bigger parenthesis, and you remove this bigger parenthesis. Can you do that? Yeah, and don't forget, don't forget the sign. Okay, so here the first one, you just remove the parenthesis without any problems. Okay, without any problems. So let's see who is here already. Yeah. All right, then minus a, but you have two negative sign here, then you change the sign. Negative becomes positive and becomes positive. Okay, so now you find out a and minus a, can regroup them, right? You can move around, right? And here's minus b plus b and plus c plus c. So it's clear that a canceled out, bb canceled out. That's just 2c. Yeah, there are some rules we have to follow. That's trivial rules. We're using certain rules like a negative x plus y is going to be negative x minus y, right? And those are the rules, very simple rules. When you remove the parenthesis, and then here's x minus y is going to be negative x plus y. Okay, so those are the simple. Also, negative x is going to be x. Okay, those are trivial rules, but it's easy to forget it when you remove the parenthesis. Okay, when you remove the parenthesis. Okay, yes. All right. So that's all. Then we're going to study a new concept. It's called the reciprocal of a number. Reciprocal of a number, by definition, if a given number x, right? the reciprocal of x, which will be written as 1 of x. This is a number when such that the product of the number with x is going to be 1. Okay, that's just definition. Okay, this is definition. And this number is also called the multiplicative inverse of x. Sometimes we say it's 1 of x. Okay, we can also say it's 1. I usually call it 1 of x. Okay. Okay, I usually call it 1 of x. Now, so 1/2 1 of x, 1 over 2 is a number. When you multiply by 2 is 1. Oh, that sounds trivial, right? But that what is 1 over 2, right? 1 over 2 is some number. Okay, it's just some number. We denote as 1 over 2, but that number multiplied by 2 is 1. This is a new concept. Okay, so the reciprocal for 1 is a 1. Why? Why? Right? It's trivial, right? Because 1 times 1 is 1. Right? 1 times 1 is 1. That's why 1 over 1 should be equal to 1. Because 1 over 1 times 1 is 1, right? So 1 and should be equal to 1 over 1. Okay? That should be the same number. Right? That's a unique number. Multiply 1 is equal to 1. And that number is called the reciprocal 1. But we also know that 1 times is 1. That's why 1. Yeah, this is a trivial argument, but we should know that. How do we prove this is 1 over 1 is 1? Okay. Now the reciprocal of 0 is undefined. Why? Okay. Formally, you can always write 0, right? Why this does not exist? If it exists, then multiplied by 0 is going to be 1, right? By definition. However, any number, okay, any number multiplied by 0, it should be 0 because 0 times any number is 0. So what happens that if 1 over 0 is a number, right? Is a number, then you have this diagram. So 0 equals 1. It's contradiction. Okay. So this implies 0 equals 1, a contradiction. Okay. So in mathematics, we have this kind of method we call the proof by introduction, proof by contradiction. So you assume, okay, this is not true. Then you, based on that, you give argument. Then you got some statement which is obviously wrong, like 0 equals 1. Then you say, okay, my original assumption is wrong. Okay, when you argue with someone, and you always use this method. Sometimes assuming you're right, blah blah blah. Then again, then blah blah blah. You argue, then finally get very, you get some conclusion based on that assumption, and the conclusion obvious is wrong. Then of course, then he's right. He's not right. Okay, so that is the way we call the proof by contradiction. All right. So now let's try to see why the reciprocal of if x is non-zero number, then 1 of x is non-zero, and it's a reciprocal of x is x. Reciprocal of 1 of x is x. The reason is that, okay, first of all, by definition, 1 of x, right? We have this idea. That's by definition, okay. Right, and then you switch it, it's x times 1 of x. Now that means, on the other hand, right, if you want to find the reciprocal of 1 of x, this should be equal to 1 of x, right? And the reciprocal of x is 1, right, by definition. So that means this 2 must be equal, right? So therefore, 1 of x, reciprocal of 1 of x is going to be x. Let's prove that. Okay, that is a proof. And then this cannot be 0 because 1 of x is 0, then 0 times x is going to be 0. It's not going to be 1. So this obvious implies 1 of x is not going to be 0. Okay, otherwise 0 times any number is going to be 0. Okay, if x is non-zero, f is 0, 1 of 0 is not defined. All right, so that is how do we prove that? Right. Then I have to quickly go through all the formulas. I'm not going to prove all of them, right? So this one is that you have two reciprocals, reciprocal of x times reciprocal y is going to be the reciprocal of x times y. Now, how do you prove this? That sounds simple. Now, if you view, we have never talked about the fractions yet, okay? There's some formula for fractions. Then this is simple, but without the fraction, concept of fraction, why this is true. Now, in order to prove this is going to be left side equals right hand side, the left hand side is a number, a product, right? So you multiply 1 of x. I want to prove this is 1. If I can prove this is 1, then it is going to be, it is going to be, this statement is going to be true, right? So how do you do that? So you can, okay, you can remove the parenthesis, just 1 of x times 1 of y times x times y, right? Because by the associative rule, for multiplication. Then by commutative rules, and this is 1 of x times x, and here 1 of y times y, right? You can do that. You can switch two terms. Then you can also put a parenthesis there, right? You can do this first. You can do that first, right? Every step is legal, right? Mathematics is legal. And then by definition of the reciprocal of x, this is going to be 1 times 1. So 1 times 1 must be equal 1. Right. So that implies some number times x times y is going to be 1. So that implies by definition that product must be equal to reciprocal of x times y. X times y is a number. Okay, I should put a parenthesis here. Yeah. So x times y is a number. So that, yeah, this is a, then by definition, they must be equal. Okay. That is argument. Clear? Yeah. So we need to kind of, we need to learn how to prove that using the rules already proved in the book. Okay. Approved before this rule. Then we can use this in the future, step by step. Mathematics is like that. You give a very simple definition, and few rules you set, they're very basic rules. Then based on that, you build the whole building step by step. Okay. Then one above another one. Okay. So they're not contradictory with each other. So it's a solid building, and that's called, what we're doing right now, it's called the foundation of mathematics. Right? Yeah. Sounds sometimes trivial, but if you do not set the good foundation, you make mistakes. Always make a stupid mistake. So why? When I was grading the homework, quizzes for the college students, I find out they haven't memorized, the correct the algebraic rules. Okay. And yeah, so we gave a definition. This is called definition of the reciprocal. Use that, then you get this trivial state. Then after that, we can use it. Okay. And I'm not, this is like a 1 of a negative x is going to be negative 1 of x. So why this is true? Okay. Why this is true? That's also obvious, right? Sounds like that. So what you can do is you just needed to verify, you verify negative 1 of x times, okay, times negative x, okay. As long as you can prove this one, then the part on the left-hand side should be 1 of a negative x. And then that is easy to check. But we have to use some rule. We prove that at the very beginning. At the very beginning, I think we have the rules negative x times negative y is going to be x times y. Okay, so this is we already proved that the x y can be any number. Of course, could be 1 of x. Then by definition it's 1. So that implies this is going to be the reciprocal of a negative, reciprocal of a negative x. Okay, let's do some example. We already mentioned all those rules. I think first of all, we should know how to prove that step by step, right? we are on the second floor, like build a building. So the first floor, we already have learned some basic formulas. Then you go to next level, right? Then you prove those formulas, then you can use that again and go to the third floor. Okay, now let's do some exercise. Okay, let's do some exercise. And how do you, what is the best way to solve this type of problems? Okay. Now, some students will do, okay, I'm trying to, because we haven't learned the fractions yet, okay? You cannot just use a fraction, formulas for fractions to add them together and then multiply this out, okay? This is not the way I want you to do, okay? So what you can do is, think about this. How do we, so 1/2 plus 1/3 plus 1/4, you cannot combine them into one fraction because we haven't started fraction yet. Okay. So what you can do is apply the rules a b plus c equals ab plus ac. Okay, this is the rule you can use. Okay, so it's 2 times 3 times 4 and times 1/2 and plus 2 times 3 times 4 times 1/3, 2 times 3 times 4, it's 1/4. Okay. Then you switch around and in the exchange two terms, I think this is a 2 times 1/2 and here's 3 times 4, right? And this will be, I move to 4 to the right. I can always regroup them. And this is same here. It's 4 times 1/4 and 2 times 3. Okay, regroup them. Okay, right? Because AB equals BA. Okay, and then this will be 1. So you got 3 times 4 and plus 2 times 4 plus 2 times 3. Then you compute each of them. Okay, then you get 12, 8, 6. Okay, so it's going to be 26. All right, that's how do we do that. Now, I repeat again, you cannot add those 3 reciprocals together because we haven't studied the fractions yet. We assume you cannot jump to fractions. We don't view 1/2 as a fraction at this moment, just a reciprocal of 2, some number. Okay, it's a reciprocal of 2. All right, now the motivation to introduce the reciprocal number is because we want to define the division, the quotient, a divided by b. Okay, a divided by b. Remember, compared to the one we do now, right? How do you define a minus b? We define a minus b as a plus negative b. Remember that? Yeah, we define the plus first. Plus is associative and commutative. Then we define negative b. Then a minus b is defined to be a plus negative b. Okay, and here's similar situation. We define reciprocal of b, and we define the multiplication. Okay, multiplication is associative and commutative. Then we define division as a product of these two numbers, a and reciprocal b. Okay, so that's the definition. Okay, so 3 divided by 2 is actually 3 times 1/2. Okay, 3 times 1/2. What is that number? We don't want to talk about this right now. Okay, so this is actually I'm not going to mention the value. You know that, right? So it's 3 divided by 2. If you use a calculator, it's just 1.5. Right. Anyway, so let's just prove this. X divided by negative reciprocal y is x times y. How do you do that? Now let me give a proof. Okay, x divided by 1/y is x times 1 over y, right? Remember that, right? By the above definition. So 1 over the reciprocal of the reciprocal of y is y itself, right? So that's all we have this identity. Okay. We remember, you know, we already proved that the reciprocal of the reciprocal of y is going to be y. Okay. All right. So this is another formula we can use that in the future. And so don't make mistakes, you know, 28 divided by 1 over 7. And that is actually 28 times 7. Okay, not divided by 7. So be careful. If it's multiplied by 7, then you know, right? Yeah, this is multiplied. Yeah, this is multiplied by 7 actually. Okay, so that is going to be yeah, you can multiply this out. Okay, so 28. Okay, times 7. So this is going to be 196. All right, now let's take a look at this problem. How do we do that? Okay. Well, we just look at this problem first. Okay. Now, some students will try to add them together inside the parenthesis. That's not the way I want to do. Okay. When you get the problem, you look at the problem first. Is there any short? Is there any short you can yeah. Is there any short way to do that? Okay. Okay, so now we can do it, right? So you see that when you look at all the numbers, you see, okay, I have 2, 4, 6, 8, 10, 10, 8, 6, 4, 2, right? So actually you can reorganize. It's 2 plus 4 plus 6 plus 8 plus 10, right? So you don't need to know exact value. This is a sum number divided by same number. It's identical to the same number, right? So sum number, same number, right? So you can, so that's why this is just equal to 1. You don't need to waste time to add all the numbers together. So when you are given a problem, don't just do the computation for the numbers inside the parenthesis. You should look at whether you are able to find another simple way to do that. Okay, don't waste the time. Okay, all right. So we have to mention a couple of formulas, and A times B divided by A times C. A should be, A can get rid of that. You know, you can get rid of A and just, yeah, A times B divided by A times C. This is going to be B, just B divided by C. The common factor A will be canceled out. Okay, so common factor A will be canceled out. Okay. Okay. You know why? Yeah. The reason is, yeah, you can, the reason is, let me give you a proof, okay? A, B, by definition, you have to use the definition, A over C, right? Then you remember, we already proved that this is going to be 1 over A, 1 over C. Then you reorganize it, and the 1 over A times B times 1 over C. And this is going to be 1. So 1 times B times 1 over C, but B times 1 over C is B divided by C. Okay, so that's it. All right, so that's why you know, if we, after you study fractions, that's also easy to see. Okay, the common factors in numerator and denominator should be canceled out, but we're not going to talk about fractions right now. Okay, so if we do the next problem, right, 205 times 205, and this number is divided by 205, and just because that's a common factor here, right? So if you can write it in a slightly better way, if you want to apply the above formula, you know, you need to express in the following form, and the 205 times 1, okay? Then you have 205, it's the same number, it can cancel out, and then divide by 1, and divide by 1 is just multiply by 1 over 1, right? And then 1 over 1 is 1, right? That's just 205. Okay. So how about the next problem? Yeah. So the next problem, you just get a common fact. Okay. Yeah. Okay. So the next problem, you will see that the common fact, you can cancel it out, right? So what I'm going to do is I'm going to do the first. It's going to be multiply by 100 and divide by 8 times 100. So 100 is a common fact. Now that's all 100 can be gone. Okay. And then 648, 40, you know, divided by 8. You can also you can say it's just 80. That's fine. You want to continue, give more details, is 8 times 80, right? You know, then divide by 8 times 1. So then 8, you know, apply the formula. So just 80 divided by 1, that's just 80. Okay. I can, why somebody give me 800? So that should be 80, right? So be careful. Okay. All right. How about the next problem? What is the number 10 more than the quotient when 78 is divided by 1/2? 78 divided by 1/2. Yeah, 78 divided by 1/2. You just need if you understand the question, that would be not complicated. Yeah, just write down 78 divided by 78 divided by 1/2, and 10 more than that, just add a 10, right? Okay, so that's gonna be 78 divided by, then it's multiply just by 2 and plus 10, and 72 multiplied by 2 is 156, okay, plus 10, so 166. All right, that's all we can get. Now the next one, I'll let you to try first, okay? Anyone has answers?
I have one.
Oh, okay. I got different answers, but don't post it to everyone. Okay, okay. So this is going to be, yeah, we can do it step by step. Okay, and yeah. So be careful when you put the parentheses, there, right? Yeah. So I think this is the formula we can use here is yeah, this can be written as 1/2 divided by 1/2 divided by 1/2 divided by 1/2. Okay, that's legal, right? Yeah. So then this is going to be, because it's a, you see, remember, AB, yeah, AB divided by C, okay? AB divided by C is 8, you can write, yeah, it's not, doesn't matter, just multiply this or AB times 1/C. So you can group them together, first two, right? Otherwise, you have to use a parenthesis there. So that's clear that 1/2 divided by 1/2 is 1 divided by 1/2 divided by 1/2, right? Then this you can also put a parenthesis here, right? That when you put a parenthesis here, the first one is just 1 times 2, so it is just the 1 times 2 divided by 1/2, and that's 2 divided by 1/2. Okay, 2 divided by 1/2 is 2 multiplied by 2, so that's why it's 4. All right, so that 4 is the answer. Okay. All right, now sometimes if you view it as a product, that's could be wrong. It's 1/16. Okay, so you cannot randomly put the parenthesis here. If this A times B divided by C, right? This cannot. Yeah, if I have two division here, this is not going to be A divided by B times C, for example. They're not equal. Okay, or divide by. You cannot put the parenthesis over C and B. Okay, you can, after you simplify, let's see what is this one. This is A times 1/B, right? And time divide, yeah, this is then divide by this time 1/C. And this side is A divided by, right? A divided by, it's a little bit complicated, B times 1/C, okay? Then you have to A times 1/B times 1/C, okay? Then you can also prove that, okay? Then C can go to the top. Actually, it's going to be A times C times 1/B, but then they're not equal, clearly. So be careful when you put the parentheses there. Okay, so this is yeah, it's easy to make mistakes. Now, how about this next problem? What is the best way, quick way to solve this problem? Okay. When you see so many sevens here, okay? When you see so many sevens here, okay. When you see so many sevens here, okay, so we separate them first. Okay, we separate them first. So this is going to be 7, 7, 7, 7, 7, 7, 7, 7, 7. 3 groups divided by 7 plus 7, 7, 0, 7, 7 divided by 7. Okay. Okay. Then clearly this is this common factor here, right? So 1 times 7. So divide by 7. And this is going to be 1 1 0 1 1 times 7 divided by 7. Okay. And the same 7 should be gone. Okay. So 7 7 is gone. And that 1 1 0 1 1. And then you add them together. Okay. So be careful about this. How many numbers here? So you got 1 1 1 1 1, right? And then 1 2 2 0 2 2. All right. 2 2 0. And this is 1. Yeah, 1 plus 0 is still 1. Okay. So 1 2 2 1 2 2. Right. Yes. How many ones up front? It's a 5 ones. Okay, don't type too many ones there. Double check. Okay. So that's why we have to usually have to use a common here, because it's not easy to count them, right? So that's why we put a common here. And then it's not decimal point, okay? Then you don't want to write too many digits there. Okay. All right. Well, so now then take a look at the next problem. Okay, is there any better way we can solve this? All right. 124 plus 1, 4 plus 84 plus 64, 44, 24. All right, then 6 divided by 6, 62, 52, 42, 32, 22, and 12. Okay, what is the best way to simplify it? Yeah, as you can see that each of them is going to be 2 times 62, 2 times 52, 2 times 42, 2 times 32, 2 times 22, 2 times 12, okay? Divided by 62, 52, 42, 32, 22 plus 12, okay? So here you get the common factor. So you can take a 2 out, times 62, 52, 42, 32, and 22, and 12. Divide by 62, 52, 42, 32, 22 plus 12. But you don't need to know the exact value of that. And you can also express like a, this actually divided by this actually is divided by 1 time that. So those common factor can be canceled out. So it's divided by 1. That's just equal to. Right? Yeah, that's equal to. So do not add all the numbers together. Now, if we want, it's easy to find out. We have a formula. We're going to talk about this later at the end. Okay, how to add a sequence of arithmetic sequence of numbers together. Okay. All right. So let me mention some formulas again about the division. We have to be very careful about the use of these formulas, and I'm not going to give a proof of all of these formulas, but I want to mention the first one. Okay, how do you get that? A divided by B, A plus B divided by C. By definition, this is going to be A plus B times 1 over C. Then we use a formula. It's going to be A times 1 over C, B times 1 over C. And that is back to the original notation, right? So therefore, you have Abba's identity. Okay. So we get those formulas from the formulas for multiplications. Remember, division is just a special multiplication. Subtraction is a special type of subtraction. As addition, So subtraction, right? Remember, subtraction is A minus B is A plus. We view that as addition. And division, we view that as a multiplication. Okay. So we basically don't have a two type of operations, addition and multiplication. And then subtraction and divisions are not brand new operations. We define it using addition and multiplication. Okay. All right. Okay, let's take a look at this problem. What is the value of a 314? 314 divided by 1001. Okay, so let's think about. Don't use a calculator. Okay, you cannot use. You shouldn't use a calculator. Right? Shouldn't use a calculator. Okay. So first of all, you will see that if we don't use a calculator, so what we do is we're going to separate them. Okay, that's the first step. Then 314 times 1000 plus 14 times 1, right? So you have a common fact, right? So that's going to be 314 times 1001. Now, if it's divided by 1001, what is left? The quotient should be 314. Okay, so that implies 314 divided by 1001 is going to be 314, right? Okay, cool. All right, now take a look at this problem. Express it in the simplest form, 8 divided by -4. Okay, multiply by, sometimes we will put a dot here, sometimes we don't. Multiply 4 minus 8. Let's go back to the formulas I did not prove, but we can use it. Is those formulas here, right? X divided by negative y is going to be negative x divided by y. So negative sign can be always freely move out, right? Negative x divided by negative y can take out to negative signs. Negative x divided by y is going to be negative parenthesis x divided by y. So using this, and this you can get negative 8 divided by 4, right? Right, and this 4 minus 8 is -4. So 8 divided by 4 is going to be 2. Now you have a negative, right? So this both negative is going to be 2 times 4, and that is going to be 8. All right. Yes. Great. The next one. We try to find the sum of the digits in the answer to the problem. Now we just needed to figure out how to multiply them out. Okay. So you have, I'll give you the hint here. Okay. So you have 50 digits here, first number. And the second number also, yeah, each number is both have 50 digits. I should have said that. Okay. So we multiply this out. Yeah, so I have to say that it's a 9, 9, 9, 9, 9, 9 times 3, 3, 3, 3 here. I have 50 digits. Okay. I have a 50 here. So the idea is that you have to use a hint. You will get 1,000. No, 1,000. Just too many zeros here, right? And minus 1. Okay. So you have a 50 digits here. Okay. Right. And the multiply. Okay. Then you will get. Okay. You add I needed to add the 50 zeros. Okay, 50 zeros minus, you have 53 here. Then you needed to do subtraction. Okay, when you do the subtraction, you have to borrow, right? How to do that, right? How to do subtraction, right? Yeah. So you have to borrow the digits. The last one is a 7 because you get 10 here, right? You get a 9 here, blah, 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 blah. You get a 9 here and you get 2 here, right? Right? So you get 3, 3 all the way to 3 and the 32, yeah, 3, 2. Okay. And the 9 minus 3 is a 6 and all the way to 6, and here 10 minus 3 is 7. So this will be the answer. Okay. This will be the answer. So from here to here, you have 50 digits, right? Okay, got it? And then you can add all the digits together, right? Then you can add, so after you get these answers, then you can get all the digits together. Be careful when you count them. Okay, so you have 50 digits here, and then you have a 50, you have a 50 digits here, right? So add them together, the sum of the digits. You get how many is 3 here? 3 times, I think, 49 plus 2. And here's a 6 times, I think, also 49 plus 7. Okay, then you add them together, you will get the answer. Okay. Add them together, you will get an answer. Okay, let's do the calculation. All right, so 3 times 49 plus 6 times 49 plus 9. Okay, 400, I think it's 450. Okay. Yeah, 450 is correct answer. It's not 447, it's 450. You can do also, you can do this way. As long as it's computed, it's 9 times 49 plus 2 plus 7 is 9, right? So you have add them together, it's 9 times 50. So that's why it's 450. Okay, that's another way to do it. Okay, now I'm going to spend a few minutes talking about the sum of the arithmetic sequence. We have this formula. So if you know this is the arithmetic sequence, that means every next term, you know, the terms in the sequence increased by a constant number. Okay, in that case, the sequence is called the arithmetic sequence. The sum of this all the terms in the arithmetic sequence will be the average value of the first term and last term divided by the number of terms. Now, if you use this formula, I'm going to prove this formula later, okay? So when you're given this formula, somebody gives you this formula, you should know how to prove it. So let's use this formula. So the first term is 5. This last term is 100 divided by 2. So the question is how many terms there? In order to figure out the numbers of terms, okay, you needed to express this term as like that. 5 times 1, 5 times 2, 5 times 3. The last term is 5 times 20. So 1, 2, 3, 4, all the way 20. So that is why that was 20 terms here. Okay, so that 20 terms, not 100 terms, the 20 terms. Okay, so this 105 times 10. So that would be the answer. Okay, so now let's prove the theorem, because when we use this, we have to give a proof. Okay, we have to give a proof. Okay, proof. You let S to be A1, A2, A3, all the way to the AN, right? So you reverse the order. Okay, then when you add them together, it's twice of S, and you get this term, A1 plus AN, and A2 plus AN minus 1. Because this is an arithmetic sequence, all of them have the same value. Okay, that is you know, because it's a arithmetic sequence. So that's why, that is why, you know, they're all equal to A1 times N multiplied by N, because all the terms are same value. Okay, the same value because it's an arithmetic sequence. So that's why S is going to be divided by 2 and multiply the number of terms. Okay, we can look at the problems here, right? We can look at the, you know, if you don't use that formula, just 5 plus 10 plus 15, right? Plus 20 all the way to 100, right? So you let S to be that. Then you reverse the order. Okay, it's 95 and 90, and here's 85, reverse the order, and that's against 5. So when you add them together, the left-hand side is twice of S. So right-hand side, okay, vertically, you always get to 105. 10 plus 95 is 105. 15 plus 90 is also 105, you see? And the 105 and the 105. All you need to know is how many terms. So there are 20 terms. There are 20 terms. So that's why it's going to be like 105 times 20. And then S is just 105 times 20 divided by 2. And the 20 divided by 2 is 10. Right? So it's 1050. That's how do we get the answers. So the two, first of all, you have to make sure this is a arithmetic sequence. Second, you have to count how many terms there, okay? And in order to count how many terms there, you needed to express them in a very nice way so you can see the number of the terms. Like what I did is because all of them are multiple 5, so that's why, I express them in the following way: 5 times 1, 5 times 2, 5 times 3, 5 times 20. So clearly, all the numbers are labeled by 1, 2, 3, 4, all the way to 20. So there are 20 terms in the sequence. So that's clear for 20, right? So yeah. And then you solve this problem. Okay. So I hope everybody memorize this formula for the sum of the arithmetic sequence. Okay, I discussed this briefly before in the elementary math class. Okay, so let's stop here, and you're going to get a set of homework. Most of the problem will be review problems and challenger problems.